Okay, well, before I start this presentation, I just wanted to acknowledge that I'm joining from Vancouver, which is on the unceded territory of the Coast Salish peoples. And this includes the ancestral traditional territories of the Musqueam, the Squamish, and the Tsleil-Waututh nations. Additionally, if you're joining from somewhere else and you're curious to know whose land you're on, you can find that out at native-land.ca. So this is like an interactive map which shows the territories of the First Nations across all of Canada. So yeah, my name's Alex Myers. I'm a machine learning engineer at Unbounce. I'm currently focused on the ML platform. And I'm going to talk to you today about how to fail successfully. So what am I talking about exactly here? So we've had a lot of really fascinating talks about wonderful things that other people are doing. So I figure maybe talking about stuff when it goes wrong might be quite an interesting change of pace. So what I mean by failing successfully in this context is I'm talking really about times when you've got a mental model of the system that's not working, and your mental model guides you towards a solution. So in order to maybe better illustrate this, I came up with this fantastically detailed Venn diagram here. So if we have a thing, an app, an ML model, a system, and you've got your mental model of that thing, failing successfully is when your model of the thing is right. And looking at the opposite state, which is when it's working, the thing is working, but not for the reasons you think it is. I'm calling that succeeding failingly, or maybe succeeding unsuccessfully would be a better turn of phrase. But what I want people to do in the audience is to think about a time when you've been working on a system that was succeeding failingly, and then that system went wrong. And I want actually a little exercise for people as they're paying attention to my talk. Use the chat, maybe describe your problem in emojis only, and I'm going to try and guess what went wrong. So that's a little exercise for people to be doing during my talk. But the purpose of this is I'm going to share some stories about how the ML teams at Unbounce have attempted to move towards failing successfully with some of our recent releases that we've made. Before I do that, I'm going to just quickly give you some background about our company and about how our teams work and our systems. So first of all, Unbounce, if you're not familiar, is a Vancouver-based company. It's a conversion intelligence platform, and we're here to help small and mid-sized businesses accelerate their conversions through pre-optimized landing pages, copy creation, and conversion optimization tools. So far, we've been around for 10 or 11, 12 years now. We've powered over 1.6 billion. It's probably way more than that at this point, actually. I think this is old information, but 1.6 billion conversions. And that produces a rich data set that we can use to provide AI insights and also to help small businesses grow smarter and faster. So we originally started as a landing page WYSIWYG builder. And for those who aren't familiar with what a landing page is, it's if you imagine a marketing campaign, it's the point where you arrive at a company's website and you're displayed a page of that company. And there'll be some kind of, normally a conversion goal that they're wanting you to click through to get to the next stage of the funnel. So, this could be a charity that's wanting you to join a mailing list, or it could be an e-commerce company that's wanting to get you to partake in one of their latest deals. Unbounce does a lot more beyond landing pages now, though. So we have some full-featured ML offerings, something called Smart Traffic, which I'll explain in a little bit more detail later, and a tool called Smart Copy, which is uses GPT-3. It's a kind of a prompt to text generation tool. And we also have a new version of our builder called Smart Builder, which is integrating a growing number of ML-based features. So the teams that actually deliver ML at Unbounce, we have a central group that handles ML, and they're called data products. And at the time of these stories, that included 2 data scientists, myself as the ML ops developer, and an additional cross-functional developer who's experienced in both data science and data engineering. And typically we interface with stakeholder teams from other parts of the company to help them realize the ML component of a feature that they want to release. And these ML features are released through a system that looks a little bit like this. So most of our inferences from models come from SageMaker real-time inference endpoints, and we have a system called Model Broker, which is set up to field requests to and from those models. And we have another system which we call Insights Manager, which acts as the interface between the sort of ML platform and the UI. And then we talk about things, just for the sake of this talk, insights and versus inferences, where an inference is the output of a model. An insight is the combination of that inference with other data to produce some kind of suggestion for the user. So the projects that we were working on during the stories that I'm about to tell, we had two. One is called for a feature called behavior sets, and this is an insight that uses a decision tree model to surface highest converting traffic segments. And this is a companion feature to smart traffic, which I mentioned before. So smart traffic is our most mature ML-based offering. It's been around for, I think, 2 or 3 years now. It's a reinforcement learning algorithm, a naive Bayes contextual bandit that uses traffic data to figure out where to send traffic across multiple variants based on the conversions or the conversion rates of previous traffic. So it's really cool and it works incredibly well. It really blew us all away, really, with how much of a difference it made, like a 20 to 30% lift in conversion rates, which is definitely nothing to sniff at. But it turns out it can be quite difficult to understand like why it works, or who it works for. So this is where Smart Segments comes in. It allows you to actually visualize like, okay, this page is doing really well with people from Albuquerque who are using Android devices, for example. And this is a kind of insight that's very valuable to our customers. Another feature that we were working on in parallel with another team is for a feature called Copy Assistant. And this is an inference, so a direct real-time response from a model. And this particular model is a combination of a set of functions to talk to GPT-3, where we submit a initial prompt to generate text. And this is then fed to a customized BERT model, which ranks the text based on its likelihood to improve conversion rates for that page. And the outcome of this is all of the text you need to get started with a landing page to kind of accelerate the process of creating a new page. Okay, well, that's probably enough background. Getting on to the first of my two stories, and it begins with John, who's one of our data scientists, who says in Slack, here's a puzzler. And I'm sure you all know that's code for something has gone wrong, please help. So in this case, we were dealing with the behavior sets model. We were in the process of optimizing it to run quickly or more quickly. For those who aren't familiar, the SageMaker real-time inference endpoints, if you use the way we're calling them, they have to return within 60 seconds. So what we were noticing, though, as we were improving performance, is that if it went over 60 seconds, at the model, the logs we would see from the model indicated it was being called multiple times. So this is a concern. It looked like it was actually a race condition of some kind, which would have, if we didn't investigate it further, could potentially result in, a log jam that might take down the system and affect other production models. So it was something very important to look into. Our mental model of our systems at this point told us that the only place this could be happening is Model Broker. So looking at Model Broker in a little bit more detail, Model Broker is actually 3 separate services. It's deployed to Kubernetes. So there's an API, a dispatcher service, which is what talks to SageMaker endpoints, and a rendezvous service, which takes the results and writes them into a database. So it's a rough implementation of the rendezvous pattern for those who are familiar with that sort of technique for handling models. So in this case, again, our mental model told us the only part of the system that actually talks to the model is dispatcher. So the thing that's going wrong must be going wrong in dispatcher. Now, dispatcher is a not a new piece of code. It's been around in production for over a year. It hasn't changed dramatically in that time. So the fact that something was now going wrong, it was a bit of a question mark. We kind of ran out here where our mental model sort of failed us in terms of telling us where to look. And also, Dispatcher is a multi-threaded application, which means that looking at the log stream can be quite difficult. You have all of the different threads just logging whenever they want, so it's hard to get a sense of a timeline from requests. So, but all we knew is that effectively Dispatcher was taking a message off the queue and contacting the model, but then it wasn't getting to the point where it deletes the message in time before that message becomes visible again and is then consumed again. And that hence is the race condition. To get a better sense of what was going on, we decided to actually include the thread ID within our logging messages. And this allows us to then filter the logs by a thread and get like a sort of timeline of events. And this was important because until we did this, we had no real way of easily testing our mental model to know whether we were actually right in assuming that things should be working. And it turns out that we weren't right. Our mental model was wrong for how this system actually worked. So what we saw when we looked at the resulting log stream for a single thread, we were raising an error when we expected to, when the thread timed out. But it then took 4 more minutes before we actually saw the thread complete. And that meant that's more than enough time for the message to become available again and picked up by another thread of Dispatcher and contacted again. And there you go, there's your snowball. So at this point, we knew our mental model was wrong and we knew sort of what was going wrong, but we didn't really know how to actually go about fixing it. And so, this is just an example of like a very simple query, and we're an AWS-based company, so we're using CloudWatch Log Insights. So the one thing at this point where we were kind of stuck, we realized that maybe we're missing the forest for the trees. So what I mean by that is that when you're querying logs, logs are a sort of document data model. There's no fixed schema for what might show up in those logs, what fields there might be. So by filtering at all, you might miss unintentionally some valuable information. And in this case, that was exactly what was going on. When we removed some of our filters and focused in on a specific time zone where we knew that we'd had a thread that had produced this issue, we were able to see a whole bunch of like messy stack traces that helped us zoom in on what the problem is. And in this case, we found that while we were right that the invoke endpoint method times out after 60 seconds, Boto3 automatically retries any method that fails several times. So hence 60 seconds, we get the timeout error, but 4 minutes later, so 5 total retries was when the actual thread completed. Oops. But that's not all. Our mental model for Dispatcher was also wrong. And this is the more important thing that I think we learned here. We didn't fully understand threading. So it turns out if you raise a timeout error on a thread in Python, the thread isn't killed. The thread continues until it, determines in its own sweet time, terminates in its own sweet time, sorry. And in this case, the real issue is that the context manager wasn't exiting until the thread completed. So what it would have been better is if there was a timeout error, we sort of handle it in that sort of part of the statement. So, and we didn't catch this because we made the wrong assumptions in the unit tests that we had. And ultimately, it also leads us to ask some questions because, you can't understand everything. Like, I think you can't necessarily know the intricate workings of the, client tools from other companies that you're using to build your system. So where is the boundary for where your mental model is okay with becoming fuzzy? We obviously learned that where it was incorrect because it encompassed a system that we have full control over. And another question this led us to ask is, can we program more defensively at that boundary? So can we engineer our system to be okay with ambiguity from things beyond it, to fail to sort of fail successfully, to go back to the topic of the talk. So yeah, it was a very, very valuable lesson that we learned from this first of our two stories. On to the second story. Again, John, our data scientist, asks the R&D team, like, based on previous model deployments, do we know how the SageMaker endpoint handles multiple concurrent requests asking for a friend? So I want to point out, John has showed up in both of these examples, and that's not because he is part of the problem, but because he's just extremely good at knowing when to ask for help. So this is a positive. I just don't want anybody to be going out there and blaming John. Anyway, so in this case, this was definitely a slightly sort of eyebrow-raising situation for most of the people within data products. Again, we've been using SageMaker real-time inference endpoints for over a year. We have multiple features running in production. And as far as we knew at this point, they were running fine. So our mental model really was like, well, the system is evidently okay because all these things are working fine. The issue must be the model. So we spent a bunch of time debugging the model without really getting anywhere. And at this point, I believe we reached out to Tavis, who is our principal engineer, and we're like, Tavis, we need help. And Tavis suggested taking a Chaos Monkey sort of false injection approach. So for those not familiar, Chaos Monkey is a tool that's made by Netflix, and it's designed to randomly kill parts of your application so you can test how the rest of the application handles it. So in this case, our Chaos Monkey approach was to create a model that is designed to not work properly. So it just basically times out so that we can, it was actually useful for testing the previous example too. But in this case, we just set it to do nothing for 20 seconds and then fired a bunch of requests at it in parallel to see what happened. And this lovely little vignette from Slack here, where Tommy, who's the director of data science, was asking, how did it go with your testing? And Tav is saying, we solved a mystery and we're amazed. So what exactly was the mystery that we solved? Well, all of our models had been processing one request at a time for the entire time. So here is a reenactment of how we responded to this discovery. That's me in the bottom left. Yeah, this was an extremely humbling, astonishing discovery that our entire system had been running single-threaded. So how on earth did this happen? Well, again, it was due to our mental model being wrong. But in this way, in this case, we made assumptions that weren't true. So our model deployment pipeline system is something that has been built by a succession of developers who've moved onto other roles within Unbounce or other roles outside. And in this case, there was a bit of misinformation around how the models are served. So the assumption was, SageMaker real-time inference is a managed SageMaker service. They're responsible for the server configuration. We aren't. Until we looked in a bin directory of each model and found that there was a serve shell script, and then looked in the serve shell script and found that, oh, it's our job. And what in that shell script, we were enabling threads. But if you don't say how many threads you want, well, you get one, which means you're running single-threaded. So there was our problem. And in this case, a super easy fix, but in a place that we would never have really thought to look had we, again, not found a way of testing our mental model. Additionally here, it made us realize that we'd been misattributing other bugs that we'd seen as being maybe because of, under-provisioned instances. So we jumped to a conclusion that turned out not to be true, which meant that not only were we dealing with this new issue, we were also spending more than we needed to on our provisioned instances for previous models. And it is also worth pointing out that it was kind of amazing that we went this long without realizing this. And this really is down to the fact that our other production features that we have using the system just happen to be very, very low latency. So some of them were dealing with 16,000 requests a day, but they were, which is not a huge number, I know, but they were able to deal with that number of requests because they returned in a very low amount of time, milliseconds instead of seconds. Okay, so overall, what were the outcomes from both of these stories for the ML team at Unbounce? So we realized that there were gaps with our mental models, and there were important questions about where is the boundary, the termination point of our models, and is it far enough into the operational side of our systems, or do we need to get a better understanding of how things work? And it also gave us a chance to realize that we needed to improve how we test our assumptions as well. So this has resulted in a growing number of methods that we can employ to actually validate that we know what's going on. And it's also had a cascading effect through other related systems, where I think now we're asking the question of, do we understand how this works? And if not, how can we test our understanding? And yeah, as mentioned, because we've been misattributing the fault, now we can save money and reduce latency across all of our instances by configuring concurrency properly. So that's going to save us a lot of money. The issues that we found them during the release cycle as we were getting ready to release these features. That we would not have been able to release either of them had we not fixed these bugs. So we found them late in the process, but the fact that we found them before we deployed was instrumental in their success. And despite the fact that we found this, and actually many other issues with these two projects, we were still able to deliver both of them on time. So I think that's a great credit to not just the data products team at Unbounce, but also the teams we work with. We delivered 2 ML features to production in a month, effectively, of working time. So pretty cool. And lastly, these 3 last bullet points I think go without saying, but I feel it's worth calling them out. That communicating effectively through Slack when you encounter those issues, and you saw examples of that kind of communication in this talk, is really valuable, and it's a skill that we've learned over the last few years. I think we've got a lot better at. And another technique which has been very helpful is just creating an ad hoc Zoom meeting, no agenda, no meeting notes, just a place for people to join so that they can collaborate on identifying a fix. That definitely helped speed up the process of getting things working. And finally, no blame. This was one that I didn't even really think about until close to the time of this presentation, but Unbounce has worked very hard to have a culture of no blame when things go wrong. So much so that it didn't even occur to anybody to be asking that question. Instead, everybody was focused on a solution and collaborating and working together. It's pretty good because most of these were probably my fault. So anyway, and the last thing as well connected to that is that we always respond quickly when people are in need of help. You can ask. I could ask the principal engineer at Unbounce, and he will join a Zoom call at short notice. I can talk to the director of data science, and he'll join the Zoom call at short notice and be extremely helpful. And I think these are really valuable things to have at a company. That's everything from me. Thank you so much for listening. And yeah, Unbounce is just like all of the other companies that we've talked today. We are hiring. We have data scientist positions open currently. So there's more information about that on our website. Anyone interested, please feel free to contact me on LinkedIn. I'd be happy to pass your details on to the relevant people.